Analyzing the physical universe as a computational system changes our perspective on classical physics paradoxes. They stop being mysteries and become software bugs. For over a century, physicists have documented a behavioral anomaly at the subatomic level, the observer effect. While philosophers have spent decades debating the implications of this effect, we are going to look at the exact same data as system analysts. In standard academia, the realization that light and matter behave differently depending on observation has caused immense confusion. Rather than attempting to force classical mechanics to explain an impossible observation, we can decompile the universe's source code. This process is an audit of the reality engine's performance logs to expose the underlying architecture of the environment. The double-slit experiment functions as a strict bounding box query. This schematic maps the anomaly. Unobserved electrons act as a wave in multiple potentials simultaneously. When a measuring device tracks the particle, it acts as a system data request. The engine responds by collapsing the wave function, resolving the matter into a solid particle. This behavior maps a clear conditional logic loop, where the physical state of matter shifts in response to a data fetch request. To map the actual pipeline, we must first address the legacy misinterpretations of this data, which function as a logic virus in the study of physics. This terminal graphic highlights the primary esoteric error, the conclusion that human consciousness shapes physical reality. This theory assigns unnecessary supernatural attributes to standard software mechanics. The universe does not require a soul to function. A computational system requires only an event trigger to execute a localized script. Software developers rely on a foundational optimization protocol known as Frustum culling, or lazy evaluation. To save RAM and compute cycles, an engine only renders the geometry that exists inside the user's immediate field of view. Objects outside that viewport remain unrendered. The engine refuses to calculate data that cannot currently be seen. Scaling this constraint up to a cosmic level allows a simulated reality to manage infinite datasets. Calculating the exact position and spin of every single quark in the universe simultaneously would cause a catastrophic server load. By utilizing those same lazy evaluation tricks, the system manages entropy and keeps cosmic compute requirements at zero for unobserved space. The universe is an optimized architecture that refuses to waste server resources on unobserved data. When reality is not rendered in high resolution, the system uses a low-cost probabilistic state. Unobserved matter is left in a compressed, low-cost format, the probability wave. We define observation as an avatar query. Targeting a specific space initiates a hard data fetch, forcing the engine into a just-in-time rendering sequence, resolving the file into full resolution. This three-step pipeline maps to the double-slit experiment. When a camera at the slit requests location data, the pattern on the wall changes to reflect a rendered particle. This localized rendering operation generates coordinates in a millisecond. Quantum mechanics is the back-end code executing a local just-in-time sequence to fulfill an avatar's data request. To finalize this audit, we can run all competing theoretical frameworks through a systemic diagnostic check to see which codebase compiles. This diagnostic ledger maps historical theories against the raw anomaly data. The 19th century classical model assumes an always rendered universe. It fails to parse the double-slit data, resulting in systemic error. The esoteric model introduces supernatural variables into a clean physical system and is rejected for lack of parsimony. The lazy rendering model views the observer as an avatar, triggering a data request. It is the only framework that accounts for localized wave function collapse using standard computational logic. Treating the universe as a dataset aligns the mechanics of quantum collapse with standard resource management protocols. The mechanics governing our universe follow administrative logic. Quarks, spin, and position serve as variables, and compute cycles render around us when requested, and returning to a low-cost probabilistic state when the viewport shifts. We are operating within a hyper-optimized digital architecture. Quantum physics is the decompiled manual for the reality engine. Process terminated.